Leonardo da Vinci, a great artist and an extraordinary innovator. He created some of the most wonderful works of art ever known. His work in understanding of anatomy and engineering was astonishing. He made detailed notes on these subjects. Famously, he scripted these in his unique style of mirror image writing, which had to be read in reverse. He was an inspirational Renaissance man and a genius. Leonardo moved to Milan in early 1480s. He was hoping to gain a commission from Ludovico Sforza. The Duke was already familiar with his artwork. So Leonardo also proposed some of his engineering ideas. Among these drawings there were some ideas for weapons and few ideas for flying machines. The aerial screw was one of these machines. He probably thought being able to fly over different territories would have many advantages, including collecting information and rapid troop movement. Interestingly, the aerial screw drawing was made before Christopher Columbus happened on the Americas, and 400 years before the Wright brothers carried out the first powered flight. This drawing is considered an original design of a flying machine. Astonishingly, it predates Newton formulating his laws of motion and Bernoulli's principle of fluid dynamics. Yet, based on his nose, it is very clear that he had a good grasp of aerodynamics and mechanics. In his notes he writes about air resistance. He reasons that due to air resistance, a man hanging from a large enough material could slow down his descent. Today we know this as a parachute. He studies birds as they glide. He notices how they maneuver their wings as they react to the airflow around them. He compares this with the power of the wind in a sail, which propels the boat forwards. He goes on to describe how rate of air displacement is important to lift. He uses the example of a man in water with planks of wood strapped to his arms. He points out the fact that the faster the man flaps his arms, the more water is displaced per second, which results in rapid upward movement of the swimmer. He argues that a similar upward movement in air could be achieved by a man with the correct type of wings. Leonardo devised an experiment to demonstrate how a wing can lift a set weight. He proposed building a 20 baraccia by 20 baraccia wing, which in SI units works out to be approximately 12 meters by 12 meters. When connected through a lever system to a 91 kilogram or 200 pound weight, as illustrated in his drawing, he hoped it would be able to lift the weight. The concept was the faster the wing is moved down, more air is trapped underneath it. This builds up air resistance, which stops the wing from moving down. In turn, the pivot is shifted to the top of the wing, causing the weight to lift up. This condition is temporary and is dependent on how fast the air escapes which is trapped below the wing, hence the need for fast rate of flapping. Most of the designs of his flying machines had wings and complicated mechanisms to allow the pilot to move the wings and fly like a bird. But the aerial screw was different. The aerial screw design is thought to have been drawn at some point between 1487 to 1490. The different elements in its design are easy to understand. There is the base disc and pole, which hold the whole structure together. Next there is the treadmill, which sits on the base and it is free to rotate. The main element of the design which is the most inspired part of the structure, is the helical rotor. The helical wing or rotor is connected and turns with the treadmill. Leonardo wants a very tight and strong build to create as much stability as possible. He is very precise about the design and the measurements of the rotor. In his notes, he describes the helical rotor as having a radius of 8 baracha, or 4.76 meters, and being built using thick steel wire. The helical rotor shows the extent of Leonardo's insight. After his passing in France, his notes were moved to Milan. Here the notes were sold randomly. So it is very difficult to discern the chronology of his notes and how his thought process developed, due to how the notes were separated and rebound out of order as it changed hands throughout the centuries. The rotor can still be considered a leap in design. The helical rotor is unique in its conception when compared to the rest of his flying machines. In creating a rotating wing, he has eliminated the need for flapping wings, which meant no drag is caused by a wing returning to its starting point. This design is more efficient since it displaces air downwards at a constant rate, creating possibility for more lift. The aerial screw worked by having 4 men walking on a treadmill, which turned the helical rotor that enabled the machine to fly. But there are problems with this. There are limitations to how fast a human can make the rotor spin. This meant there would not be enough lift considering the overall weight of the structure and its occupants. We must remember that he did not get the chance to experiment with this machine. These drawings were at the preliminary stage of the design process. He drafted his ideas in the hope that he might be able to get funding to test them further. It wasn't until 17th to 20th century that through the works of scientists such as Leonhard Euler, Isaac Newton, Daniel Bernoulli, Claude Louis Navier, Gabriel Stokes, and Henri Coandă, that engineers gained a mathematical understanding of conservation of mass, energy, momentum, and principle for fluids with their relationship to pressure changes. Yet, in 1490s, through his work with wings and flying machine designs, Leonardo's understanding of air compressibility and how this can be used mechanically was apparent. Although his calculations on weight to lift ratios were inaccurate, he did discover the essence of flight theory, which was an upward lift can be achieved by displacing air downwards. Moreover, the essential element of his design, the rotary wing, exists in most flying machines in the world today. And now it also exists on Mars, where on 19th of April 2021, the first powered flight on another planet took place. The Mars helicopter, known as Ingenuity, is a twin coaxial rotor helicopter. It was mounted underneath the Perseverance rover, which was launched from Cape Canaveral on the 30th of July 2020.
Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
On arrival to Mars, the rover was parachuted to the surface.
Heat shield set.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface. We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
Perseverance rover carrying Ingenuity touched down on the 18th of February 2021. Ingenuity is an autonomous aircraft, and its mission is an experimental one. The aim was to discover whether parrot flight could be achieved on the thin atmosphere of Mars, which is 1% that of Earth. While on Earth the rotors need to spin at 500 RPM to displace enough air for liftoff, on Mars the rotors need to spin faster in order to create enough air pressure difference to achieve lift. Having twin rotors helps with this issue. The upper rotor pushes air down to the lower rotor, which in turn pushes air down with increased pressure, achieving higher lift force. Also, if Ingenuity had used single rotor, it would have problems with counter-torque. But twin rotors help to neutralize this by spinning in opposite directions. Additionally, the engineers at JPL had to bear in mind, due to atmospheric differences on the two planets, the speed of sound on Earth is 340 meters per second, as opposed to 240 meters per second on Mars. So they had to be careful not to exceed speed of sound on the tip of the rotors, since this tends to create shock waves that disrupts lift. The other issue was the difference in gravity. Mars has 1/3 the gravity of Earth, which means less force is needed to achieve lift. To be able to test and calculate the revolutions per minute needed to allow Ingenuity to fly on Mars, NASA built a chamber to simulate the conditions on the red planet. This is known as the 25-foot space simulator. This chamber is sealed, so the atmospheric pressure can be altered to simulate air pressures in different environments. To be able to simulate gravity differences, the scientists at JPL came up with a system they called gravity offload. Simply put, they pulled up Ingenuity from above. They had to work out how to do this so that the upward force was constant throughout liftoff and flight to simulate reduced gravity accurately. On Earth, helicopter rotors have to spin on average around 450 to 500 times per minute. But on Mars, because of lower atmospheric pressure and gravity differences, the rotors will have to spin around 2,400 times per minute for lift. The first test flight of Ingenuity on Mars would only be considered successful if the craft took off, hovered, and landed. While testing out the controls, the engineers at JPL realized that to keep the aircraft reasonably steady, they had to allow an onboard computer to correct the pitch and yaw of the craft. More significantly, it was also known from the onset that due to the nature of the orbits of the two planets, at any instant, it would take between 5 to 20 minutes for radio signals to travel between them, depending on their relative position. So it would be impossible to control Ingenuity from Earth in real time. This meant that Ingenuity had to fly autonomously. Therefore, Ingenuity had to have a selection of onboard cameras to detect where it was going, means of communicating with Earth via Perseverance, and its own power source. A flight plan had to be sent out from Earth. Once received, the Mars helicopter would take off, carry out its instruction, and land. Then Ingenuity would transmit its results to Earth.
We are pulling in those data products right now. We are processing those data products. You can see AVRs are looking nominal. We see Z going to 5 meters, and then in the y-axis, which is relative to the starting position, we see the helicopter going out to 50 meters and coming back again.
There were two main elements to the usage of power. Firstly, enough power for the flight. Secondly, enough power to keep the electronics warm through the cold -73 degrees centigrade Martian night. The solar panel, which is installed on top of the vehicle, is used to recharge the batteries during the daytime. The batteries are positioned in the center of the system, so at night the heat from them warm up the electronics. Overall, 2/3 of the power will go to keep the craft warm. The rest is used for flight. Most importantly, all of these had to be packed into the smallest space possible, so it could be placed on the rover for its journey to Mars. This was achieved with precision by the scientists and engineers at JPL. They worked out a very elegant way of packing, and dismounting Ingenuity from Perseverance. Leonardo's aerial screw could be categorized as a thought exercise. He had understood the requirement for upward lift was to displace air downwards. So he made a drawing of a machine he felt could be effective. NASA and JPL understood the importance of a flying rover on an alien terrain with many difficult obstacles. They wanted to demonstrate that powered flight was possible even on a planet like Mars, with such a thin atmosphere. Ingenuity is not just a proof of concept, but it has also been an opportunity to collect data and learn how autonomous flight on another planet can be achieved effectively and efficiently. Ingenuity's logs show from 19th of April 2021 to 11th of June 2022, 29 successful flights. This is well beyond its original remit of 5 test flights within 30 Martian days. Ingenuity will no doubt serve as a critical tool towards making humans into an interplanetary species. In their own way, Leonardo's drawing of a flying machine and Ingenuity's flight on another planet represents significant leaps at the outer reaches of humankind.